let's go through worked example 11, which says we're going to find the curve of g of x given that the derivative function is 3 times root x plus 2. And g of x, which is the original function, passes through a coordinate 1, 2. Okay, so they've given us enough information now to work out what g of x is. Okay. Now let's just say, for example, that we have a derivative function and it's 2x. When we integrate it, what's it going to come to? X squared plus c. Okay, and that constant means that there's a vertical shift going on here. Okay, so 2x looks like that. When we integrate it, we know we get a quadratic. Whoa, Mr. L, what's going on there? Go Nike. Okay, there's a quadratic. Okay, but we don't know if it's up there, or if it's there, or if it's there, or if it's there, or if it's there. Okay, the vertical shift, we don't know where it is, because the c tells us where that vertical shift is. Okay, and you guys know that if we derive, let's say this was y is equal to x squared plus 7, so the vertical shift is up here. When you derive this, we get 2x. Okay, so in other words, all of these functions, when you derive all of them, you get the same gradient function. Okay, makes sense? So what we're about to do is we're about to anti-derive g dash x. It's going to tell us something about the original function. We don't know where the vertical shift is, but because they give us a coordinate, we can work out what that vertical shift is. We can work out what that constant value is. Okay, so that's what we're about to do. Here we go. So we have the derivative function, which is 3 times root x plus 2. Let's integrate 3 times root x plus 2 with respect to x. And what do we get? That's the same as x to the power 1/2. So we're going to raise that power to make it 3 on 2. Divide by that power. So dividing by 3 on 2. And then we're going to integrate the plus 2, which is just going to be 2x to the power 1. Dividing by that 1 just gives us 2x. Don't forget plus c. Okay. And so we could call this g of x now. But I have a little bit of work to do. I need to simplify that. What's that going to come out to be?
2.
2. Very good. How did you do that so fast?
3 times 2. He's swift on that.
3 times 2, 6 divided by 3 makes 2. That's true. Good. So now that we have the original function, we have it with constant c, we're now going to apply a coordinate 1, 2. And basically, when x is 1, the function should come out to be 2. I'll say that again. When x is 1, the function should come out to be 2. Alright, so put a 1 in here. And all of that is supposed to equal 2. Okay? I have one equation, I have one unknown, I should be able to solve c. So let's simplify. 1 to the power of 3 on 2 is 1. 1 times 2 is 2. 2 plus 2 will make 4. So c is going to be? Negative 2. Okay, and so we have the original function complete now. 2 times x cubed square rooted plus 2 times x, take away 2. So there's g of x.
Wait, from the original equation?
Yeah, so we have now found the original function. All we needed was its derivative with any point. Okay? Now, you guys might, when you do this question, you might be a little bit unsure at first if you've done that right or if you've done that wrong. So, how do we check? We can derive it, can't we? So if we derive that, we should get this. Let's do it. So deriving the function g of x, we're going to get that power is 3 on 2, so bring down the power. 2 times 3 on 2 times x to the power 1/2 plus 2. Twos are going to cancel, and we're left with 3x to the power 1/2 plus 2, and then the constant's gone.
Just the same. It's the same result.
Which is the same as that? Easy?
Too easy.
Okay, so have a go.